Okay. So we had some introduction about functions, right? Okay. Let's continue our discussion on function. So we saw in the last session that you have to first define a function, right? You can't use it without defining. While you're defining, you're talking about what the function is supposed to do, right? So here I said if I define n1 comma n2, and here you print, okay, n1 equal to n1, and you say print n2 equal to n2. Now I can say add equal to n1 plus n2, and you return add. Right? So when I call this function, I'll call something like this, result equal to func1, and then I add some values, let's say 10 comma 20, right? And I can print the result here. So I'll say total is, and then I'll say result. And when you run it, you get this. So what's the purpose of doing this? This is, okay, this is like block of code, which I'm giving a name. And whenever I need to perform exact same thing, I don't have to rewrite the code again. I just have to call this func1. Okay. Now, see, func1 took the value n1 10, n2 20, because we have written 10 first. So 10 goes to the first variable, first argument, which is n1. The second value goes to second argument, which is n2. Now, if I try to do something similar, but this time I give only one value. So what happens? You get error saying required positional arguments, right? It is about required positional arguments. So what we just saw is required positional argument. So there are two things here, required and positional. What is required? What does required mean? That you have to provide the value for this, right? Okay. So if there are two variables here, two arguments here, you have to pass value to the both. Now here, n1 takes the value 10 because we gave one value, n1 takes it. But there is no value for n2. That's why I got error saying that you have not provided value for n2. Correct? So this is what we say required. You have to provide value. You have to provide value to this argument. Okay. Now, if you talk about positional, why did n1 take the value 10? Why not n2? Because of the position, right? Takes the value based on the order. Or we say position. Okay. So now you have something called as default. Default is non-required kind of argument. Okay. How do you make something non-required? Here you have n1, n2, so you have to pass two values, but I don't want to pass some value. You have to make it default. When you make it default only, you can choose not to give a value. And you have something called as keyword. Keyword argument. Now, keyword argument is your non-positional. Okay. So when you talk about default here, so if you see this one, okay, this n1, n2, we have to pass the value. Okay. But if let's take similar example. I'll copy and paste the same thing here. And I call this as fun2. When I call this as fun2, okay, now it expects that I provide two values. Okay, so let's take fun2. Now it has two variables, isn't it? When it has two variables, you have to provide two values to it. Now, if I'm saying that we'll make it non-required, if I say, okay, we'll make N2 as non-required, let's say, we'll make N2 as non-required. Now, to make N2 as non-required, it's fine that you don't pass, but then it has to take some value, isn't it? That is called as default value. So in this case, I'll make N2 as default. I'll say N2 is 66. Okay. So in this case, I'm providing a value. I'm giving a default value. Assign spelling is correct. GN, right? Assigning a default value. I'm assigning a default value 66. That means, okay, when I don't provide value here, now N1 is required, N2 is default because I have not made N1 equal to anything. So N1 is required. So you have to give a value for this. Okay, so here N1 takes 10 and your N2 will take default value, which is 66. Okay, now I can call it again. I'll call it as, let's say, 20 comma 50. Okay, now since we are providing value 50 to N2, N2 will take 50. Okay, so default value will only be taken when you do not provide any value to it. Okay, when you don't provide any value to it, only then it will take default value. If you provide any value to it, it will take the value that you have provided. Okay, it will take the value that you have provided. Make sense? So default is that you provide default values only in case it does not have anything to take. If it is not given a value, that's when it will take the default value. But if user gives the value, it will take the value that the user gives. In this case, I'm giving 50. So 50 will go to N2. In this case, I'm not giving value to N2. So it's taking 66. Of course, we can have both of them as default. So this is mixed. Required, default. So I can make N2 default as -1, N1 default as -1, N2 default as 0. So I'll call this as function 3. In this case, if I call function 3, okay, and I'll say 2 and 5, obviously it will take 2 and 5. But if I don't provide any value, okay, it's going to take the default value, which is -1, N is -1, and N2 is 0. This is your default values. Now my question is, can I make N1 as default? Here, I want to make N1 as default and N2 as non-default. Can I do that?
Yeah, I think we can. I think we can do it.
We cannot do it.
Why?
Why? Good question. We cannot do it because if I'm making second value, let's say, if I'll delete it, let's say. So I'm saying N1 is default, which is -1, and N2 is non-default. Non-default. So can I give value to N2 without giving value to N1?
Yeah, order, I think.
You cannot.
Yeah.
Okay, because N2 is second variable. Right?
Yeah.
I cannot give value to second variable without going, so I cannot have, second person in the queue without having first person in the queue. Right?
Yeah.
So if I have to reach N2, I have to give, so see, if I try to give something, this is function 3, right? So if I try to give value here, if I enter 5 or 10 or whatever, okay, this 6 will go to N1, not N2. So to reach N2, I have to give value, second value. If I have to give value for the first one, then what's the point of making it default? See, default means you don't have to give the value. But if I have to give the value, then what's the point of making it default? No point of making it default, isn't it?
Yeah.
That's why you cannot have second value, non-default. So all your default values will be on the extreme right. All the default values will be on your extreme right. As you go towards left, it becomes it has to be required, isn't it? So you can have all default. Okay, absolutely no problem. So in this case, if I enter only 6, it will go to the first value, N1, not to N2. Still, positional is playing the trick here. Okay. Now in this case, I want to call a function F3 only, but I want to give value to N2. So I will say N2 equal to 6. Okay, N2 equal to 6. This is called keyword argument. So keyword because, see, when you give equal to in the function definition, when we give equal to in function definition, we are calling it as default. But when you're giving, see, this name and what you give there has to be same. You have to say N2 only. I cannot say N5, A5, A2, something, because A2 is not there. So if you say A2 equal to 6, it will not know which variable you are trying to change. You have to say N1 or N2. I want to give value to N2. So I'll say N2 equal to 6. Okay. Now if I go here, and if I don't give value to N2, okay, still it will give error. It will give error because, yes, using keyword, you can give value to N2, but not give N1. But not always people will use keyword. You're not mandatory making people to use keyword. So you have to make it default, no other option. So remember this rule is there. Okay. Your default values have to be on the right side. Non-default values on the left side. With me?
Yeah.
Yes.
Perfect. So we have seen all 4 examples of arguments. It can have a required argument. It will have a positional argument. Then if you don't want to make it required, you have to make it default. If you assign a value to the variable, it will become default. So you don't have to pass the value, it will take the default value. But to declare default value, it has to be on the right side of the argument, right? Then to make it non-positional, I want to give value to N2 without giving value to N1. Yes, you can do it using keyword. You say N2 equal to, and N2 will take the value, and N1, okay, will have its own default values. So always remember, if you have to use both default and required should be added first and default at the end. Okay. So these are four main types of arguments that you see. There's one more called as variable length arguments. Okay, you have one more which is variable length argument. Okay, so so we're talking about occasion. See, now here whether it is required or non-required, or keyword or default, we are giving n1 n2. That means you can only play with two variables, two values. But let's say there's a situation where sometimes I might enter two parameter, two values. Sometimes I might enter 0. Sometimes I might enter 12. For example, you want to find area of a image. The area of an image could be triangle will have only 3 values, square will have 4, pentagon will have 5, hexagon will have 6. Can I write a function, single function, to manage all of these? Okay. So in this case, you see, minimum required is 3. Minimum required is 3 to calculate area. But apart from minimum 3, it can have 4, 5, 6, 7 also. Isn't it? So I will write a function now here called as, okay, so let me write it after function 3. We have function 3, right? We'll call function 4. Function 4, okay, and you need to have 3 mandatory or required. Then I'm going to say star S. Star S means it is ready to accept variable number of arguments. Okay, and if you try to print it, you will see the output of this is a tuple. Okay, so I'm going to call fun4 result. Okay, so we'll just, there's no return, right? So we'll simply say print, or rather we'll just say fun4. Fun4, I need to give 3 values, otherwise it'll throw error. Fourth one, it's up to us. So I can say 4, 5, 6, 7, 8. So see, I have given 8 parameters. Okay, and here I have only 4 arguments, S1, S2, S3, and S star S. So your 1 will go to S1, 2 will go to S2, 3 will go to S3, and rest everything will go to S. You want to see, if you run it, you see, values of S are 4, 5, 6, 7, 8, because we have S1, S2, S3. Okay, so now what you can do here, since it is a tuple, you know that if len of S, okay, equal to 0, print, we are dealing with a triangle. Okay, you can say elif. Elif. If the length of S, that means we have 1. Dealing with a square or a rectangle. Okay, you can say get equal to 2. So 3 plus 2, pentagon. Right? Okay, equal to 3. Hexagon. Equal to 4. Heptagon. Okay, we'll just put 5 and then octagon. Okay, if len is greater than 5. Up to 5, we have seen it. Greater than 5, we are dealing with a shape greater than 8 sides. So in this case, you have 8. So it's an octagon. Right? So you are able to read each value. So single S, okay, is able to read entire value as a tuple. Not only that, if you want to pass some text like dictionary, okay, like here name equal to Sachin, like keyword, these are keyword that I'm passing. Name, game equal to cricket, city equal to Mumbai. Okay, now here I can say, okay, print. Okay, I have not read it. So to read double S, you have, keyword arguments with both key and value, you have to give double S. Info. Okay, if you want to say print info, you see, it will look like a dictionary to you. That's the application. Okay, I can check if name in info dot key, right? Okay, if name in key, then I'll say print name of the player is, okay, info name. Okay, let's run it and see. I think it should have single quote. Right, key is text, right? So name of the player is Sachin. Okay, I can check here. If game in info dot keys, okay, game, okay, here you have city. In info.keys, the player lives in, okay. So now when you run it, it says name of the player is Sachin, the player plays cricket, the player lives in your city, right? So now you see the second part, info takes all three information. Now if I call it again, fun4, okay, and I don't pass anything. Okay, so three values will go to three required, and your star S will have nothing. Name, I'll say Virat. Okay, and I don't give city, let's say. See, name of the player is Virat, plays cricket. Okay, city, since we did not give, we did not play. Okay, we are dealing with triangle. Values of S are blank. These are the output from your second function, F4. So you can give any number of values also. You can give any number of dictionary also, key plus value. So with star as a variable name in the function definition will save the information as dictionary. I mean, star as a tuple and double star as a dictionary, right? Okay, sure. All right. So this is how you can pass. Okay, fixed number of values. Now I want to write a function. Okay, I want to write a function. I want to write a function to check if a number is prime or not. Okay, I want to write a function to check if a number is prime or not. Okay, so how will I do it? I'm going to define here def, and I'll say check prime, and we'll pass a number, right? We'll pass a number, and this number we will check if number is prime or not. Right? So first of all, if this number has to be if num less than 2. If it is less than 2, then it's not a prime, isn't it? Okay, so I'm going to create a variable called is prime, and this will be true. So I'm setting is prime to true. Okay, and then based on the value, I'll keep changing the value. So if num is less than 0, sorry, less than 2, that means 1, 0, -1, -2, etc., then definitely it's not a prime. So I'll say is prime equal to false. And once I'm done, I will return prime, is prime, right? So I will decide later, in the main program, what to display. So here I'm saying is prime equal to true and num is less than 2, it is false. Okay, elif num equal to 2, I will say is prime equal to true. I don't have to do it because is prime is anyway marked as true. So I can avoid this bit and this step, and simply I'll say if it is more than 2, then do what? Then, okay, then we have to use a for loop. So if number is 10, so I need to start dividing that number from 2, 3, 4 up to n-1 or n by 2. Okay. Okay, I need to divide up to n by 2. And if it is not divisible by any number by n by 2, then we say that number is prime, right? So I will define for I in range 2, and it is your num divided by 2 plus 1. So if it is they are checking for 100, I'm dividing by 50 and going up to 51 so that I can check up to 50. Remember, your loop, okay, ending value is always up to, isn't it? So it's not going to go up to plus, the n by 2. So we want it to go up to n by 2. So we gave n by 2 plus 1. By 2, because you get an integer value. Okay, that's why we need. The range needs integer values only. Okay, so for I in range 2 to 4, and I'm going to divide this. If num modulo I equal to 0, that means perfectly divisible, then is prime should be false, right? Okay, it has to be non-divisible by everything else. If it is non-divisible only, it should become true. Otherwise, even if you know it is not divisible, it is false. And once okay, once you know that it is not a prime number, that means once you know that it is not or once you know that it is divisible. Once you know that it is divisible, then you can simply say is prime false, and then you can break it. So once I know it is not a prime, I'll simply break it. I don't have to check further, right? So that is it. Now let's go and call this. So what I'll do instead, I will write a for loop. I will check from 10 to 20 if numbers are prime or not, right? So for I in range 10, 20, result equal to check prime I. So it will pass I, right? And if I, that means if result, right? The result will get true or false. So if result, that means if result is true, then I will say, okay, I is prime. Okay, else I will say I is not prime or composite. Right? You see, 10 is not prime, 11 is prime, 12 is not prime, 13 is prime, 14 is not prime, 15 not, 16 not prime, 17 is prime, 19 is prime. So you see this? Okay, so this is a function which takes a number and tells us if that number is prime or not. Right? All right. So now you'll see, okay. So see the reason why your function should be should not have print and things like that, because your function should be as generic as possible. If it is as generic as possible, you can use it for multiple purposes. For example, see, I'm using this to check if a number is prime or not. Okay, I'm getting this kind of output. Now I can use same function to generate prime numbers. Okay, using the same above function to generate prime numbers between, let's say, 5,000 to 6,000. Between 5,000 and, like between we write and, right? 6,000. Okay, so I'll write something. So I'll say here print prime numbers are, isn't it? And between 5,000 and 6,000, right? So I will say 5,000, 6,001. Okay, check prime. If it is prime, I will simply print it. I don't even have to say F, right? I'll simply print I. If it is not a prime, then we don't have to print it. Okay, and I'm going to print it in a same line. So you'll say end equal to. Okay, and let's say once we are done, we'll simply add a blank line. All of them will be in single line. So come to next line, we will put print. Now you see, okay. So same function we use to check a number also and generate also. So your function should be as generic so that you can find multiple application of it, right? You can find multiple application of it. Otherwise, it's of no use, isn't it? All right. So this should be as generic so that you can use it. All right. So this is how we have seen multiple uses of your functions, right? Multiple varieties of functions. Now there is one more concept here called as nested, okay, or recursion function. Recursion function is function calling itself. So right now what's happening? I'm calling this function check prime. So check prime is executing and returning back. So it is one way. You call the function returns, and then you are done, right? Now, in a way, okay, now we are going to do a function which calls itself. Okay, so let's say I'm writing all functions together. So let me go and write here def recur1. Okay, and I'm saying recur1. So you're calling recur1. Okay, you're calling recur1, and recur1 is calling itself. This is example of recursive function. So what happens when I call recur1? It'll keep on calling itself, right? It calls and again it calls, again it calls. Now your machine cannot take beyond 996 times. So it called 996 and said stop. Finally, I'm getting into some kind of infinite loop, calling itself, calling itself, calling itself. How long can you call itself? Okay. So of course, this function has no meaning. It's totally meaningless. But there are some situations where we can use this. Okay. Which are those situations? So let's say instead of recur, let's say I make this as factorial, or I'll say recur factor. Okay, and then of course you call recur factor. Now what is happening here? Okay, I'm saying, okay, now I'm going to generate factorial of a number using recursion. Okay, so what's the purpose? Okay, how is that possible? So if you see an example of, let's say, 10 factorial. What is 10 factorial? 10 factorial is 10 into 9 factorial, isn't it? So isn't it a situation where your factorial is being called by itself? So I'm saying, what is 10 factorial? You say 10 into 9 factorial. What is 9 factorial? 9 into 8 factorial. What is 5 factorial? 5 into 4 factorial. What is 4 factorial? 4 into 3 factorial. How long can you go up to 0? Right? Because 0 factorial is 0 factorial is 1. And you don't go -1, -2. Okay, you need to stop. So you see, every recursion should have a stopping condition. It might go on for 10 times, 20 times, 100 times, 200 times, but it has to stop some point. Otherwise, it will go up to 996 depth and it will not work. So how does it work here? If I can demonstrate to you using a paint. So you have, let's say this is main program. Main programs calls recursion, right? Now this recursion, okay, recursion starts, it goes down and it calls itself. So again, it goes up, calls itself. Goes up, goes up, goes up, goes up. Now you see, till the function is completely executed, function is not complete. So you start from here and you call 1 time, then 2 times, then 3 times, then 4 times, then 5 times. And in 5th time, let's say you encounter the ending condition. You're not getting into recursion again. You got an ending condition. Once you get ending condition, then you come back and then you come back. So you will come back, like say if you start from here, okay, you start and let's say you go here, you go here, you go here, when you go here, finally here, let's say condition stops. Now you have to come back through same path. Okay, because your previous function is not completed, isn't it? You have to go back and complete it. And then you will come here. So when you encounter the ending condition, then you have to trace back through same route and then you have to reach finally your main program only. Okay. So in this example, when we are doing factorial, we are saying factorial n, right? So if you say recur factor of n. Okay. So what is n factorial? N factorial is n into, n into n minus 1. N into n minus 1. And this is the return, okay? The function has to return this, right? Which is good. 10 is 10 into 9 factorial. 9 is 9 into 8 factorial. 8 is 8 into 7 factorial. But there has to be some stopping condition. When do you stop? When you see n becoming 0. Then you say, oh, n is 0. Now return 1. No need to perform factorial, just return 1. This is the stopping condition. Your recursion function should have at least one stopping condition. Otherwise, it will not know when to stop, where to stop, isn't it? It should have at least one stopping condition. Okay. So now when you run it, okay, and here we are going to call recur factor, right? And we'll pass value 10 here. Okay. So this will give us the final output, the result. And I'm going to say print 10 factorial is the result, right? So 10 factorial is this. Okay, you can check if this is correct or not. This is example of recursion. Okay, recursion means a function calling itself. If function calls itself, then itself again, it will call itself. Itself will call again itself. It will go on calling itself. There has to be some stopping, right? So whenever you are writing a recursion function, you have to be careful because your function will get into infinite loop. Okay, you need to have a stopping condition, something that will stop. Okay, and stopping can be after 5 or 10, right, or 20. But once it stops, it comes back slowly. It comes back, and it goes back to the main program from where you have called the function. Make sense? Okay, good. So with that, we have covered, mostly like how function work, but there are some small 3-4 stuff or small things that we need to understand. One is called your module. What is module? Okay, we need to understand what is module. Module, okay, we have used few modules, right? We have used random modules. Remember, we said import and then we called, okay, we called rand int and things like that. Okay, so we have random module. Now, what is module? Module is a collection of functions. So here also you see, we ended up writing 4 to 6 functions, right? So this is also a module. This has also become a module. Your P1 has become a module because we have written multiple functions in it, isn't it? So what I'll do, I'll go to P18 and I'm going to say import P1. Because P1 is also module. That's what. See, module is just a collection of functions, okay, with its own file name. So module name is the file name. You don't have to do anything extra. You don't have to do anything extra. You simply say module is module is a collection of functions, or it could be a collection of classes also. We'll see classes in the next class. Okay, we'll start classes from tomorrow. So I'm going to say import, okay, P1. Because P1 is a module which has multiple functions. I want to use those functions. If I say P1 dot, you see, result variable is available. Recur factor, fun4, func1, check prime, func2, func2. These are all functions which are available for us to use. But let's see what happens when you simply say import P1. When you say import P1, all the things have run. It's like running the P1. Now, let's say you have written some good functions and you are using, let's say P1 is your file and you have written some good functions and you are using and you are working. I say, okay, I need those functions. Okay, since you have already developed this, why don't you give me your functions so that I will use it for my work. I will use it for my work. And once I am done, I will give back, of course, there's nothing to give back here, but it will save my time, right? If you have done those 6 functions and if I need to use the same 6 functions, I don't have to write from scratch. It will save my time. So you say, okay, you take my P1 file. You'll give me your P1 file. When you give me your P1 file, I will put it here and I will run it once. At least once you have to run it. And then I'm going to say import P1. When I say import P1, your functions are available. But also problem is whatever things that you have done, right, in P1, that is also getting called. But I'm not interested in how you execute it. My usage will be different than yours. I need functions only. Maybe you have done this one, but my objective is this one. So I'm going to use same function, but I'm not going to, reuse what you did here. I have my own set of work which I need to accomplish. So when you are writing your file, always make a habit of writing like this. Anything and everything that you want to be on main should begin with something called as condition here. I'm going to say if, okay, underscore name underscore equal to underscore main underscore double underscore. Now you see, okay, every time, okay, every time, okay, your what do you call whenever you come across this double underscore, like double underscore name double underscore, right? You remove the extra underscore here. Double underscore something double underscore. So whenever you see this double underscore, okay, it means that it has a predefined meaning. Double underscore means that word or that function, that variable has a predefined meaning, already defined. So double underscore, something double underscore means, okay. So when we write our own variable names or function name, we don't write the double underscore at both the end. And in the classes, we see situations where you write double underscore. Okay, so there are situations where you will end up writing double underscore, but we don't write double underscore on both the sides. Only one side we write, beginning we write, not at the end. So when you see something at the end, that means it has a predefined meaning. So this is a variable name which has a predefined meaning, okay, which has double underscore at both the end. The meaning of name is which file is getting called, which file is calling, which file is calling. Main is this file getting called directly? Okay, so I'm writing P1. So if I say name equal to main, that means if I right click and say run P1, then this is true. Okay, this is true. The file which is being called is same file. Okay, so I'll push all of them as a step. Okay, so this should also go here, right? Yeah. And now when you run it, okay, so when you run P1, all these will be called. Okay, because yes, you are calling this P1, so name equal to main is true in this case. But now when I call P11, okay, or Pi11 or Pi18, whatever, you are calling P1, right? That's what import P1 did when we did earlier. But now what happened? The name is okay, Py18, Pi18, not P1. This will become main, not that. So here also, okay, you should say if this is, make it a habit of writing something like this. Whenever you're writing your own file, just say if name equal to main. Okay. Now print running pi18.py. So now when I run pi18, you see, this will be run because I am running directly py18. So main will be true for this, not for this. Understood? So you have all these logic here. When you do it, it will work fine. No problem with your logic. But when I run it, I am not going to execute your logic. I'm going to access only the function. Okay, I'll have access because functions are outside the condition. If you put functions also inside the condition, then functions are also not available here. But I want functions to be available. So that's why I have put function outside and all the other code inside. Right? Are you with me, guys?
Yeah.
Okay. So now if you want to use, I can check, I can say result equal to P1 dot. P1 dot check prime 91 and (91) is prime, else print 91 is not a prime. Okay, when I run P18, absolutely it works. 91 is not a prime. 97 and is 97, right? So I have to say 97 here. So you see, 97 is a prime. So we are able to import all the functions from P1. Okay, that's how. Okay, this works. All right. So we have seen modules, we have seen functions, of course, then modules. Modules is a collection of functions. And how do you call? So when I say import P1, when I say import P1, I have to use P1 dot to call all the function. Okay, if I don't say, okay, and if I, okay, if I go to P18, now if I say import random, I have to use random dot, right? That's what you saw, random dot. Okay, random, okay, random int, etc. Now, if I don't want to call all the function, okay, I only want to call some some function. So I'll say from P1 import from P1. So P1 is you are getting access to it. Import check prime, comma, fun4. That's it. So now only two functions from P1 is available to you. And then we don't have to use P1. Now when I run it, it will give, okay, it's not giving error because I have P1 here. Okay, if I comment it, okay, it will not know what is P1, correct? So here you will say directly check prime because you are not importing P1, you are importing check prime and fun4 from P1. So now directly check prime will work if you are calling by function name. I can say here import P1 as my own module. So now if you have to call this, okay, now even if you run this now, okay, this is error because it doesn't know what P1 is because it's called alias. We are renaming P1. P1 is the actual name, but I'm saying call P1, but now from today onwards, I'm calling it as my own module. So this will throw error. Instead, you will have to call my own module dot P1. Okay. Okay. My own module dot check prime. Now there is no error. So we are seeing three ways of calling module. One, directly say import module name. Then every time you have to use module name dot function name. Module name dot function name. Second type is when you don't want to import module, you just want to import specific functions. You say from module name import function1 comma function2. Then function1 and function2 will only be available and they can be used as if they were in your same program. You don't have to use module name. Third type is renaming your module. I don't like P1. Say P1 is there, but I don't like people to say, oh, P1 module is not good. So I'll say import P1 as something else that you like. And something else that you like dot will have access to all the functions that P1 module has. So three ways of a module you can call it. Okay. This is how functions are part of a module. Once we are done with class and objects, remind me, we'll talk about packages. So modules are files which will have functions and classes. Packages are folders which will have multiple modules. So we'll talk about packages. Packages is a folder name, okay, which will have multiple modules. You can have multiple modules and group them into one single package. All right. One last thing before we end the day is that your function, when you go here, okay, you should give what is called as documentation, doc string. You should write documentation. What is docstring? Docstring is documentation and it is the first, okay, I can write it here. Docstring is the first multi-line comment in a function. Okay, when I say first, it's not first. First multi-line, first or should I write? That is the multi-line comment added in the first line. Okay, this will make more sense. This makes correct sense. It sees a docstring is a multi-line, not a hash. Hash is single line comment, isn't it? It has to be your multi-line comment. That means triple quotation. Whether you use single or double doesn't matter. It has to be triple quotation, and it has to be in the first line of your function. This is your function. This is your first line, isn't it? Here, okay, you will say this is a function that takes a parameter and returns true for prime and false for non-prime. Okay, parameter num, input or value to check, return true for prime and false for non-prime. So this is called documentation. Okay, whatever you write, that will be saved as documentation string. It is associated with your function, okay, as a documentation, official documentation of a function. Okay, so you see, you'll end up writing multiple comments. How will function know which is documentation, official documentation, which is not? So first line in your function is your official documentation. Okay, so this is your first line, and then, okay, what's the use of this? See, I have written this P1, so I know what it does. But when you are using it here, before you use it, you want to know what it's all about, right? So you will say, I'm going to write it here, printing docstring. How do you print docstring? You say print, okay, you say print your function name, which is check prime dot doc underscore doc underscore, and you do not put here bracket. Okay, you will use it like a simple variable, not like a function. So this bracket is for print check prime dot underscore doc underscore. I told you underscore something underscore is a default, means the default value, right? It has some meaningful value. So when you say dot underscore doc underscore, this will pick up the first multi-line comment and display as it is to you. Okay, so see, this is the doc value. This is exactly what we gave here. So two things we have seen, that from now on, when you are doing programming, every function you should add some documentation so that users of your function will know what they are using. Second thing is, you should write all the functions at the top, and below when you're writing your main portion of the code, you should always have if name equal to main colon, and then you write with a space, like a function, like a normal condition statement. Name equal to main has to be there in your program, so that when somebody uses your program, they'll be able to access your functions, but not your private code that you have written. All right. So with that, we complete our discussion on function. Any questions?